Okay. So I work at CloudBees. We have a lot of people working on the open source Jenkins project and Jenkins X. I'm the author of the Kubernetes plugin for Jenkins. So if you're using Jenkins on Kubernetes, that's probably one thing you use. And I'm a long-time open source contributor at different open source projects like Maven. I could ask who loves Maven or who hates Maven, and we'll probably get everybody in the room here. And I'm part of the Google Developer Experts program, doing some, because of the work I do with Kubernetes. So let me start with Jenkins X. Anybody using or heard about Jenkins X? Just some people. Let me start doing a demo, and possibly that will help you understand things better. Because what could go wrong with demos, right? So I have my application running. This is the Croc Hunter game. And it's a game that is very interesting. It's just shooting crocodiles with lasers, right? I could be playing this all day long. It's so much fun. And we can see, well, here it says staging on the URL. So this is my staging deployment, my staging environment. So Jenkins has the concept of different environments. And staging is the one that comes from the master branch. So let's say, shooting crocodiles with lasers is not very environmentally friendly. So let's make a change to this application as an application I have in GitHub. And this is on Java with Spring Boot, this particular version. So let me add a change. And let's go here, templates, index, because we like to edit on the web page. And so you see it better. So let's make a change here and say, there it is, no lasers. And I'm going to create a new branch, and I'm going to create a pull request for my change. So what Jenkins X is going to do is first is going to have this idea of chat ops, which is talking on my pull request. I can do commands on my pull request and have Jenkins X react to these commands. It's basically telling me this pull request is not yet approved, and somebody has to approve it. And there's some serverless Jenkins, and I'll talk about serverless Jenkins in a second. This is pending because the build has to pass, and it cannot be merged until its build succeeds and the pull request is approved. So let me see if I have here. Let's pull the logs first, just in case. OK, I have the logs running at the bottom. So my pull request is going to trigger a build, and the logs are going to show up here. And I'll come back to this. While this is building, what I can do, I can interact with my bot, and I can do things like meow and very useful commands. And my bot is going to answer to me with a response to these commands, right? Other things I can do, I can approve my pull request with /approve, but I'll do that as soon as the build succeeds. So what's happening behind the scenes is that this is triggering a job in a pod in Kubernetes. And this pod is going to start a new build of my application. So this is taking some time, possibly now. Well, it's already, the Maven output is down here. It's just 2 verbose to show the whole thing, OK? And it's going to do the whole build of my application, and it's going to deploy it. While this is running, I'll show you the cluster I'm using. I'm using GKE on Google Cloud. So I have this one. My cluster size is 7. I have this much memory. And I have an interesting feature, which is auto-scaling. enabled. So the more builds I have, my cluster is going to grow up. And if my number of builds shrinks, my cluster is going to shrink. So I'm only paying more or less for what I'm using. And I don't have a lot of things running all the time. All these builds are ephemeral. That's the concept of serverless Jenkins. So let's go and see. OK, it's still working there. And I'm going to open another window to approve my pull request, because I cannot approve it with my own user, as you would expect. Some other user has to do it. So getting this ready. OK. So it says my pull request is built and available in a preview environment. I go here, and I can click on that environment, on that link. And it's not yet up. 1 second. This should be up in a second. So what Jenkins X has done, it has created a new environment just for my pull requests. So I can see my changes before they are actually merged into the master branch. And that way, I can test that my changes are working or not. So I can see at the bottom the different commit, and the version, the release, is a pull request release. And I can try that my changes have succeeded. And now I'm throwing fish instead of shooting lasers. So my changes have made it. My application is good. I like how it looks like. And I can come here as a different user, and I can say approve. And I can see my comment, approve, and I see that serverless Jenkins has passed, and my bot is saying that now that the pull request is approved, so I can Jenkins can merge it now into master. So once that happens, I have my staging environment. My staging environment is going to be updated with the contents of the master branch. So as soon as all these things are merged, another build is triggered for the master branch, and it is deployed to the staging environment. OK, let me refresh. So well, this happens because, OK, there it is. So it was already automatically merged and everything. So the only things I had to do is go and review my pull request, and all the things annoying that you have to do, like merging, looking at the preview environments and all that stuff, is automatically done by Jenkins X. So let's go back to here. Jenkins X runs everything on Kubernetes. So you can deploy to Kubernetes, and it provides you very easy ways of doing Kubernetes deployments. But you can deploy anywhere else. The only requirement is that Jenkins X itself runs on Kubernetes. And it uses a lot of open source tools that are very popular nowadays. So Docker, it uses Jenkins inside. It uses Skaffold, Draft, Helm, Nexus, all these things. The most interesting ones are Helm is the most popular package manager for Kubernetes. So it will, when you are deploying applications into Kubernetes, is going to create the Helm charts for you. The Helm packaging is going to generate all the files you need, and is going to build them and deploy them. So everything you saw in my application gets packed as a Docker image. So first, the Maven build happens. Then there's a Docker image happening. Then the Helm package is putting together that Docker image and the configuration files for Kubernetes, and that gets deployed. And that's using the Helm charts, that last bit. It also uses a Skaffold, another project from Google, that allows you to build Docker images with different backends. So you can, with a Skaffold, you can build Docker images using just the Docker daemon, the normal way. It will run Docker build for you. But it has some interesting backends where you can use Canico, which is another Google project that allows you to build Docker images without needing the Docker daemon. So it's a lot more secure when you run on Kubernetes clusters. You can also delegate to Google Cloud Build. So it's running on the Google infrastructure for you. And you can also do the build with Jeep, which is a project also from Google that allows you to build a Docker image from Maven or Gradle. So it's a plugin that you set in Maven. And I don't know if it's a good idea or not, but it will do that for you. And it uses, I don't remember what the command is, but it will, from your Maven, MVN something, and then it will build the Docker image for you. The other project we use is Draft to generate a lot of these files. So when you import a new project or you create a new project from scratch, Draft will generate the Docker file and the Helm charts and all these files that you need to deploy an application to Kubernetes. So you don't even have to do that. It will look and say, oh, this is a Java project. So I'm going to generate a Docker file with using the Docker image for the JDK, and I'm going to generate the Helm charts to use that Docker image. So this is a project from Microsoft. And the one thing you saw on my demo was that the build was happening under their serverless Jenkins. So you have two options with Jenkins X. You can run traditional Jenkins. So you get the same Jenkins you always seeing, the Jenkins you love or hate, running the Jenkins master and everything. All your builds will happen as agents in Kubernetes. Or you can choose to use serverless Jenkins X. So serverless Jenkins X means there's no Jenkins master running all the time. It's every time you get a new commit webhook from GitHub, and this requires today, it requires GitHub only, but we are working on adding Bitbucket support. Every time you get a new webhook, then a new pod in Kubernetes is going to be created, new containers, and when the build finishes, that all goes away. So you can scale, you can have thousands of builds at the same time because every build is totally independent from each other. It uses YAML to define the pipelines. So instead of using the Jenkins file, you can use YAML, and I'll show you in a second. And it stores everything, whether you use serverless or non-serverless. With Jenkins X, everything is stored as Kubernetes custom resources, which basically means all the data you have for your jobs and builds and configuration. It's stored on Kubernetes, so it's highly available. And if your your Jenkins master goes down on the non-serverless or on the serverless side, all this configuration is stored on Kubernetes. And you can query this with the Kubernetes API. To do that, it uses a project called Tecton, which is a project that came from Knative build. So Knative is the serverless, open source serverless project that Google created, and build was a specific part that was doing the creation of Docker images and all the build part for Knative. That got split out into Tecton, which is basically a pipeline engine for Kubernetes, where everything runs on pods and containers, and each step runs on a different container. So we are contributing to the Tecton, and we are using Tecton to run Jenkins X serverless builds. We use Prow, which is a project coming from Kubernetes also, the Kubernetes infrastructure. This is what implements the ChatOps facility that I show you, where you can do comments on your pull request and it will talk to you. And it's the thing that handles the GitHub webhooks. So it handles the GitHub webhooks, Prow, and then it calls Tecton to run the actual builds. The way this all works when you create new projects is that you select a build pack. And we have 2 repositories with build packs. And each repository, well, one is for traditional Jenkins and the other one is for Kubernetes Jenkins. And you have different build packs for different languages, different stacks, right? You have a build pack, and I can show you here. So you have build packs for Golang, Gradle, Maven, Python, Scala, etc. And this is basically what defines what your pipeline looks like. So we're looking at standardizing the whole pipeline, so you don't have to define what the pipeline looks like. If you are a Maven project, it's going to be a very straightforward, and although you can customize it. So for a Maven in Java 11 project, I just have to put this jenkinsx.yaml file in my repository and say my build pack is Maven Java 11, and I don't have to do anything else. That's what I have in my app here. Jenkinsx.yaml. So instead of having to define the whole thing of all the different steps, I just say, I'm using the Maven Java 11 build pack. And this defines a set of standard steps. So it's a bit complicated on the way because different pipelines extend each other. So if you go and look at the Maven Java 11 pipeline, you're just going to see that it extends another pipeline. So you have to go and look that pipeline and the parent pipeline to know all the steps. But if we go into detail, so this one extends another pipeline. If you go into detail to the original, to the top parent pipeline, you will see that there's two pipelines defined. One is for pull requests, one is for master branch. And for pull requests, what I'm saying is version set, this is just increasing the version number. And I'm doing a Maven install. There's more stuff, but this is basically one of the important bits. And this is what it's doing on the pull request. For that release, what I'm doing is, well, setting the version, the same thing, increasing the version number, because Jenkins X with these build packs, what it's going to do is automatically increase the version number on every commit. And what I'm doing then, it's a Maven clean deploy. So I'm deploying this to my repository. And this is all predefined, so you don't have to copy that over in each project. You can extend it with adding pre-steps and post-steps, so you don't have to copy the whole thing, but you can still customize to your needs. And the interesting part is that both worlds can coexist. You can have a Jenkins classic, Jenkins master running, and you can have serverless pipelines if you have new projects that you can use. It's a lot more convenient and scalable if you have new projects. Okay, so let me show you, for instance, more things that I can do. One other feature of Jenkins X is the creation of devpots, what we call devpots, and I can do JX create devpot. JX is the command line that will do everything, interact with the Jenkins X Kubernetes resources. And I ran this before, but this basically creates a pod running on Kubernetes that has my whole stack for my application. And it's synchronizing my local contents to the remote contents. So I can list, this is all happening in Kubernetes, so I can see my jenkinsx.xml. And I can do my Maven build. And this is all happening in the cloud. So I could do a Docker build also. And everything happens on the cloud. So I don't have to, I'm not constrained with my laptop resources. Everything is happening on the cluster. So if you have to do a Docker build and a Docker push, then if you are in your local internet, it's going to take a long time. But if you are already in the cloud, then it's gonna happen faster. So that's one thing I can do. I create these devpods that will help me develop with my application without having to set up my whole development environment. And this is synchronized, so I can still use my editor locally and do commands in the remote side. I can create a new project, basically saying JX create quick start. And I can choose from different templates that we have. So let's call it JNation. And I can choose, I don't know, a Spring Boot with Gradle, for instance. There's multiple templates. And it's going to create this Git repository. For me, it's going to create the scaffolding, all the files, the templates and everything, the Helm charts, the Docker files, all that stuff for me without me having to do anything. And it's going to be added to Jenkins X. So now, if I go here, I can see my project. So it's the template, and in a second, this should start building because it gets automatically added to Jenkins X. So it took me like a few seconds to just create a new project and import it into Jenkins X, so I can start working on it right away. Let's see. 9 seconds. Okay, this is the new Serverless JNation. So that's going to take my new project and start building it. So you see Maven, oh, well, this is Gradle now downloading the internet, it's not Maven, sorry. So it's going to download all the dependencies. One thing that also we do with Jenkins X is that we incorporate a bunch of services that you're going to need. In the cluster, in the Kubernetes cluster, we also have a Nexus running. So everything that you download is local in the network. You are not going to the internet every time. So we have this Nexus proxy to do the builds. Because every time, you know, the slowness of this is when your cluster scales. For instance, you get a new node, and that node has nothing, so you don't want to go and download everything from the internet. We use Nexus for all the Maven dependencies. We use, if you run on Google, we use the Google Container Registry for images. So it's pulling from the same cloud, so it's not going to Docker Hub or anything like that. So we are optimizing a little bit where to get the resources from. So this is going to get run and deployed eventually. And while that happens, let me continue. One thing I've been working on lately is what we call progressive delivery. So progressive delivery, it's something that makes it easier to adopt continuous delivery, where basically you deploy new versions to a subset of users, and you check that it works for those users before rolling it out to everybody. So think about blue-green deployments, canary deployments, incremental rollouts, things like that, that were only available, or people like Facebook and Netflix are doing. But the thing is, you don't have to be Facebook to do this, because it's very easy if you're running on Kubernetes. And if you're running on Jenkins X, I'll show you how to do that very simply. So continuous delivery is very hard. I mean, you don't want to continuously deploy things and not knowing if it is going to work in production. So progressive delivery helps you achieve that, because only a few users will be affected in each case. And those users could be even internal users first. So you could deploy and say, I want only internal employees to see this new version. And if everything goes well, I want to roll it out to external people and end users. Or I could say only 1% of users, and if everything goes well, 5%, 10%, whatever. So this gives you the safety of implementing continuous delivery in a safe way. So how can you do this with Jenkins X? We are using a bunch of open source projects that you can find, and Jenkins X is also itself open source. You can install Istio, Prometheus, and Flagger. So we use Istio. Istio is a service mesh for Kubernetes, and we use it for traffic control. We use Prometheus for metrics. So all the metrics from your application are going to be stored in Prometheus, which is a popular metric server on Kubernetes. And Flagger is a new open source project that allows you to automate these canary deployments. We installed this as Jenkins X has this concept of add-ons, and it's very easy to create new add-ons and just install them in your cluster. So it's installing some Helm charts and then configuring this to work with your Jenkins X builds and application deployments. So Istio has a lot of features. Now there's like 30 different projects doing service mesh on Kubernetes and outside of Kubernetes. So it has allows you to do connection between secure connections between different services, control, create policies on what can talk to what, and we are going to use it mostly for traffic shaping. So saying some percentage of traffic is going to this version, some percentage of traffic is going to this version, and also for observability. When you install Istio and you enable Istio in some deployment, it's going to get all the traffic metrics from that deployment automatically. You don't have to change your application at all. And it's going to send those metrics to Prometheus. So response times, response status codes, all these things get monitored by Istio itself. I don't have to touch my application. I haven't instrumented my application at all. This is all going to be happening on the Istio side. Flagger is this open source project that automates the promotion of canary deployments. So what Flagger does is continuously look at, OK, there's a new version being deployed. I'm going to, instead of sending all the traffic to this new version, I'm going to tell Istio to send some traffic to this new version, like 10% every 1 minute. This is the demo I'm going to give you. 10% every 1 minute to the new application. And it's going to look at the metrics in Prometheus, the Istio metrics. And it's going to say, OK, if there's an error or if the rate of errors increases or the response time increases in this case, and you can use any other metric, I'm going to automatically roll it back. So it's going to do a staging rollout and detect if something goes wrong and do an automatic rollback. So you don't have to do anything. The way this works is you just need to create some Helm files in your project. And it's configured with a canary section. So in Helm, you have this values.yaml that allows you to define the templates of the configuration files. The interesting bits here is I'm saying, OK, enable canary deployments. I'm using this Istio gateway, which is basically where the traffic is coming through. And let's do canary analysis every 60 seconds. And if my metrics fail 5 times, then roll it back. And the step weight and mass weight is like what are the steps? So I'm going from 0 to 10 to 20 to 30 to 40 to 50% of the traffic, and then 100. We don't want to roll it more than 50%. If 50% of the traffic is good, then we'll roll it to everybody. So this is basically what the configuration is saying. And for the metrics that we're going to check at the request total, which is the success rate, so responses that are not 500 errors, and the duration. So we want 500 milliseconds to be the top, the maximum response time. So we don't want, if we consider a failure if the response goes over 500 milliseconds. And we're going to check these metrics every 60 seconds. And the only thing we have to do to enable this is to promote our application. So I talked to you about Jenkins X environments. We have a staging environment, we have preview environments for each pull request, and we have production environment. So staging is always updated with master. Production is the whatever version I want to decide to go into production. So if I go and look at my production application, I have the release 0015 here, down here. That's the one I promoted. So, and I can also see that with JX get applications. It will tell me Croc Hunter Java is 24 in staging, 18 in production. I roll it back before, and that's why it's not matching. But I can do JX promote, and let me tail the logs first. Well, let's do that later. I'm going to promote Croc Hunter Java version 0024 environment production. And let me see. Oops, that's not what I wanted to do. Session. Okay, never mind. I'm on a tail, Kale, that's the flagger. I'm gonna tail the flagger log so we see what's happening. And I'm going to do a curl loop so you see the version that is being served every time. And so this is here. Hunter-Java. I'm gonna copy this. Oops. Okay. So this is the version being the response from my production application. So it's 0015. And when this gets deployed, we'll see the versions switching. Okay. So here it is. My Flagger has detected that I deployed a new version. I promoted the version, and it's basically saying new revision detected and scaling up the production deployment. So you have two deployments happening at the same time. I could do kubectl get -n jx production deploy. So I have the primary, which is the previous version, and the default, which is the new version. And I have both things running, and Flagger is going to send traffic to one or another based on the rollout that I have defined. If we look here, we see advanced JX Croc Hunter, Java production, canary weight is 10. So now 10% of my requests are going to the new version. And you can see here, in some places, I'm getting the new version already. So some users are getting the old version, some users are getting the new version. And I can possibly verify it here. So 0015, if I refresh enough times, there it is, 0024. So my new version is being served to some users. The other thing I can do is a Flagger provides me a Grafana dashboard, and let me configure it. So I want the primary and the canary, and refresh every 5 seconds. So I can see the success rate of the new version, the canary version, and I see the success rate of the old version. The request volume, a bunch of different metrics, the request duration, CPU usage, memory usage. So you could create patterns of deployment based on any of these metrics. You could say, if memory goes over this level, I'm assuming my new version is bad, so automatically roll it back. And while I'm talking, it has rolled it out to, it has tail here. So for whatever reason, and that's the good thing about these canary deployments, you don't know what could go wrong. For whatever reason, it's telling me, hey, the request duration was 2 seconds, one in the last minute or something. So I'm halting the deployment. But because I have a threshold, I think it's 3 or 5 now, it's not gonna stop my deployment unless it happens 3 or 4 or the number of times I have defined. So it's continuing here, and now the canary weight is 20. So now 20% of the users are getting this new version. And as I said, if whatever happens, if the new deployment fails, it will do automatic rollbacks. So I can continue to see this. The way this works is using, if we go into the details, Istio has this concept of virtual service that allows you to define very complex rules of traffic. So it's sending some traffic to the primary deployment, some traffic to the canary deployment, and Flagger is automatically changing this virtual service based on the rules I set and looking at the metrics from Prometheus. When this is done, it will change the virtual service to send all the traffic to it will fold the canary deployment into the primary and then send all the traffic there. So a different way of saying this is it's scaling both versions, the old version and the new version, and sending more and more traffic until it kills the old version and just runs the new version. And this is the Grafana interface. It also has a Slack integration, so you can say, okay, send my data, send all these events to my Slack, so you can get notifications there. Okay, so this is the application if you want to take a look at it. And now it's in 40%. I don't know if I can make it fail right now quickly enough before it finishes. Let me see if I'm fast enough. I can create a, okay, yes, while true, oops, to, down. Yes, okay, so I'm generating 500 errors. Let's see if this has, okay, this is still in 40%. Oh, okay, it was too late, so it already succeeded. And where do I have this? Grafana. Yeah, it was too late, I think. Anyway, that's always the timing. Copying. So it finishes, it has finished. Let me cancel this. And I should be here. Okay, now this is staging, this is production. And I have 0024 all the time. Let's look at the, oops. Yeah, I'm getting 24 every time. So this has gone through the 5 minutes of deployment and checking every time, and everything is automated, so you can now deploy on a Friday night or any time you want, because you have the safety that if something is broken, it's going to be automatically rolled back. And because at the end of the day, you can only test for things you know that can fail. You don't know what users are going to do and what your application is going to do in production. So this type of methods help you understand production and running these experiments or running this test on production, so you know you get the real traffic and you are not risking, you're testing on the real user environment. Okay, so if I'm gonna let some time for questions. So if you ask me one question, yes. Do you have a mic? Yeah. Sorry. Yeah. If you don't have much traffic, you mean? Okay, so the question is if it makes sense to do it when you don't have a lot of traffic. Yeah, that's interesting because, for instance, what Flagger will do, if you don't get any traffic at all, then you don't get any metrics. And Flagger will not roll out if you don't get any metrics because it assumes your application is bad. Because there's no traffic, so it's like something is wrong with your application, right? Yeah, I guess it depends on the use case and on. If you still have some traffic, like nothing at all, you could say roll out and increase the rollout every hour or every 2 hours or something like that. So you could still do this with longer term. 1 minute is just for the demo. You don't want to roll out to users in 1 minute because 1 minute doesn't give you enough time to assess if something is right or not. But if you had traffic, then yeah, why not? Even if it's not a lot of traffic. Yes. Yes.
I don't know if you know about Atomist.
Atomist, yeah.
And how it compares with Jenkins X, because it's sorry, but it's too late. How does it compare feature-wise and technology-wise?
How does Atomist compare to this? I read about Atomist. I'm not familiar with it. So I don't know exactly. I know they're doing some things like that. What we're trying to do with Jenkins X is to automate the whole flow from source to deployment. So this was like the last mile, the last bit, the progressive delivery part. But yeah, sorry, I'm not familiar with Atomist. More questions? Yes. Okay, so the question is, if you need to have a lot of infrastructure when you have a big number of services and multiple PRs happening at the same time, I'll tell you that infrastructure is cheaper than engineering time and problems in production. So even the more you have, the more automation you need. So yes, if you have two people requests at the same time, then you're going to have multiple you're going to have staging, 2 preview environments, production. You're going to have all these things, right? But the difference of the cost of not doing that, right, is you merge a pull request that you have not checked or checked not enough, or you're deploying something. So it's up to you what you want to do, but my suggestion is like the cost of infrastructure now is ridiculous compared to the benefits. Yes. Yes.
For some reasons,
Yes. Separate clusters for staging and production. Yes. I don't know if it's released or not, but we have something for that. Yes. Because it's a very typical request to have different clusters for staging and production. And even different cloud providers or things like that. Yeah. Yes.
The example you gave was for a single application, but usually your application will be, or in our experience, the application will be split up into different modules, maybe different microservices with dependencies. Can you deal with that with the setup you have, and how do you deal with that? Right.
So the way Istio works is going to do this rollout would happen for each service. So you would even have internal canarying. So if you have a service that talks to another service, if you want to enable canarying, you can enable it per service. So you could have different services have canary in between them. So if you roll out like a new service and that new version is bad, you're going to detect it because traffic is going to start sending errors and having high response times. And then it's going to automatically roll back those internal services. So this is not only for external facing applications, but you can enable it for each individual service.
Specifically, so if I have an API that depends on another API, and I make a breaking change, can I state in my deployment that I need to deploy them in a sequence?
Okay. If you have to deploy things in a sequence, you are having different problems. Because if you are trying to deploy things in a sequence, in a microservices architecture, the number of problems you're going to hit are going to be a lot more than just this. What you would do, typically, is you have versioning of APIs, and then you're going to release new versioning of APIs while the old ones are still working. That was the whole idea of having microservices, that you can have different services provide different API versions. If you need to roll out things in a sequence, you're going to have all sorts of problems because how far away is this cascade? What if this rollout doesn't happen? I mean, there's a lot of issues with that. I would not recommend it. This will help you in the way, if you make a breaking change on an API and you have a dependent service that is not aware of that, once you start doing the canarying and this service starts hitting the new version and you broke it, you're going to notice. So there's going to be notifications happening. There's going to be a rollback happening. So this will help you with that. Yes? More questions? By the way, I have stickers there, Jenkins stickers that you're going to love on that table over there. I always forget about them.
One question. When you roll back, is it possible for you to define the steps of the rollback? For example, if you want to do some kind of procedure to correct the data or stuff like that? Or it's just rolling back to the old version and then you need to check out what you broke and fix it in an ad hoc manner?
So it's not a rollback in the sense that I'm removing one version and deploying another version. I have both versions running at the same time. Rollback is just pointing the traffic to one or another. So you can get notifications, you can subscribe to events, and you can do other things. But basically, what's happening is just you're sending traffic to one or another. There is no, I'm going to change this version, this deployment for this deployment or anything like that. It's just switching traffic. Because the whole point was that you have both versions, so there's no downtime between one or the other. There's no like, oh, I have to stop this version and then start a different version and things like that.
So a real challenge that you have is, for example, a relational database that you did schema changes.
Yeah.
You cannot use the same database for the progressive.
Yeah, that's the challenge that have been around for like 20 years. And, yeah.
All right.
You gotta make sure your changes are backwards compatible, and yeah, the relational database schemas, that's always hard. Yeah.
Thank you.
Okay. I'm out. Okay. Thank you. Obrigado.